My dearest loves, let's talk about how we start off these energy and questions. In this case, we're working on creating the mathematical relationship, right? Making the equation that shows what's actually happening. You've all rolled marbles down the ramps, but coming up with a mathematical way of actually predicting what speed the velocity should be at the bottom is really the work. So the first thing is to just figure out, what do we mean about the energy at 1 and the energy at 2? So we're going to talk about that, right? Determining what do we mean by 1 and 2? What do we mean by 3 and 4? And also talking about the energy relationships and the types of energy. So if you feel like you can look at this problem right now and say what equations you would use at 3 and how that equation will be different from the equation at 4, skip this. You're good to go. If you're like, Miss, I do not know what you just said, this video is for you. So the first thing we're talking about is explain the relationship between the energy at 1 and 2. What the hell do they mean by 1 and 2? So this is 1, and you know that because this is the velocity at 1, right? And it says Mina releases a marble from rest at point 1. So this is 1. And this then makes, right, when they talk about determine V3 in terms of H1 and G, blah, 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 blah. The speed at point 2, this is point 2. Okay, so this is 1. This is 2. That makes this one 3. Right? It's where H3 and V3 are. And this one's 4. So that's just how we talk about these kind of pictures. Right? Usually the little subscripts tell you what actual location we're talking about. Okay? So there's that. Next thing we're going to talk about is what is the relationship between the energy at E1 and E2. So there's energy here at point 1. There's energy here at point 2. Right? So this is E1. That's the energy here. And this is E2. That's the energy at this point. We assume, right now, particularly this point in the year, we assume that this is a closed system. Right? All of the energy here at E1 will become all of the energy here at E2. Right? So if you stand at the top of the stairs and fall down the stairs, the higher you are up the stairs, the more quickly you're going to fall down. Right? The nice thing about this, reason we're using marbles and rolling them down ramps, is we don't need to worry about any other types of energy right now other than gravitational potential energy here and kinetic mechanical energy here. Right? This is the energy, kinetic energy of the marble moving. This is the kinetic energy of the marble moving. Here, mechanical energy because it's moving. And up here, there's some stored energy. And that stored energy is from the gravitational field, right? If this marble was in the middle of space and there was no gravity, it would not roll down the ramp. Right? So there wouldn't be any gravitational potential energy. But in this case, the energy here at 1 is going to become all the energy at 2. So let's look at 3 and 4. What's the relationship here? We have energy here. What are we going to call that? E3, right? Because this is 0.3, H3, V3. So there's energy here at 3, E3. And it's going to become the energy here at 4, right? So E4. What kind of energy is there here at 3? Here, there's potential energy, gravitational potential energy. It's going to become kinetic mechanical, right? Kinetic energy because it's moving, mechanical energy because it's moving. So E3 is going to become E4.